Good morning, afternoon, or in an evening, wherever you are. Welcome by this new Areopa webinar about it is not C Sharp, but it is AL, object-oriented development in AL. I'm Bert Verbeek, your host. I'm new. This is my first one, so if everything's go wrong, you can blame me. And it is already the 88th Areopa webinar, and Andrzej will present this subject, very interesting subject, and later on he will introduce himself. Some housekeeping rules. Your mics are muted. If you have any questions, you can just put it in the questions window. And I've discussed it up front with Andrzej that I can just interrupt him so he can then answer your questions. This webinar will also be recorded and published on YouTube. So just go to YouTube and then Areopa webinar, and you can subscribe there also if you have got a notification on the latest webinars that are published. And if you want to know what's up in front, you can register also to the Areopa webinar newsletter. So then you know what the subjects are and what are coming. And what will be next? The next one is about technique for optimizing Dynamics 365 Central for Milan, more about how to optimize the code. Then Julio will close this season, season 5 already from Areopa webinar about the telemetry with AC Data Lake. And then AJA kicking off the new season about selling Copilot to your customers today. And then Luke and Christopher is about the on-lightning fast test automation and solidized code and revised test. Those are the planned webinars. So if you have any suggestions or any new topics that you want, just bring it up, and then we want to publish it. And we are always looking for new webinars. And then the last slide, I want to thanks for NAV about our sponsor providing this webinar. So thanks for that, and it's up to you, Andrzej.
The presentation. I hope that you can see my screen. Can you see it?
I can see it.
Good. Good. Okay, perfect. Thank you very much. Thank you for the introduction, and we can start. So the subject is, it's not C Sharp, it is AL, and the smaller subject is object-oriented development in AL. So first, quickly about me, so you know who is presenting it. So my name is Andrzej Zwierzchowski. I'm currently working as a development standards lead at the NAV people. I'm also a developer. I got the Microsoft MVP title last year. As I said, I'm a developer. I'm working with AL, sometimes CAL, and C Sharp and JavaScript. Those are the languages that I'm using. And I'm the author of the ACAL DevTools extension for VS Code. There is also a GitHub account where you can see the source code of this extension. Sometimes I'm posting something on Twitter, and sometimes very rarely on the blog, because it has the lowest priority of those all things. If I have time, I rather prefer to focus on improving the extension than blogging, but maybe I should also post something on this blog from time to time. So that's me. Now, let's go to the subject. So why this subject? I was presenting it for the first time, and people were asking if I could explain more why I'm talking about this, why I'm talking about this C Sharp and AL and object-oriented development, why I'm talking what I'm talking about on this presentation. So first, who is the audience of this presentation? And it's for all types of developers that are working with Business Central. So I want to address those developers that know AL and also know .NET or JavaScript. They are working with both of those languages, all of those languages. But I would like to send the message like, do not overcomplicate your solution. Yeah? Don't bring too much. Try to draw a line somewhere. But I will come to this later. Why I think this way, and also the audience would be AL developers that know object-oriented development. Yeah? The question is, can your object-oriented programming knowledge can be applied to our cases, to the things that we're doing in AL, or maybe this approach that you know from OOP should be slightly changed. And also for AL-only developers, I want to show you how we can improve your code and how to think differently about the code that you're currently writing, and also to give you some arguments when you're talking with people that came from other languages, to give you some arguments to explain why the code that we are writing is written this way. And so I would like to address all of those groups of those people. And now, again, why I'm talking about it. So I started thinking about this presentation when I was looking at the code and different solutions, different extensions. When I saw, and reading something on the internet and seeing some problems that we're having, or challenges that we're having, or mistakes that we sometimes make in our code. Like sometimes you see the code and you see that the code is over-engineered. Like you see that we're solving the problems that we don't have. We're using sometimes design patterns that doesn't fit into the problem that we are trying to solve. Sometimes we as a developer see some code and see, some technology and think, that's cool, I want to do it. But it's not necessarily the thing that we should be doing when we're solving the problem. Sometimes we're so focused on the technology that we are forgetting that that's not the place, that's not the best case for it. Yeah. And sometimes we're just forgetting that we need later to maintain the code. And if we create something overcomplicated, maybe you will be the only person that knows how to maintain this code. And we have 20 developers, and it's so complex that only you know how to fix the problems, only you understand this code. And maybe it also is not a good idea to write it this way. But we know all that creating simple solutions is hard. So all the things that I mentioned above, they happen because it's really complex to know. And I also have to say that sometimes I also did those bad things. So quickly, one more slide. What's about why and what kind of problems you see. So here are some quotes that they saw. Like sometimes AL developers can say, you should put your function inside table because it operates on this table, and that's what you will do in OOP. You will have your object, your classes should have, in OOP, your classes have the methods and properties and some hidden variables inside, and those functions are operating on this internal state of the function. That's why every function should be in the object. So every function should be in a table because it operates on a table. And that's what you're doing in C#. Yeah? Somebody may told you that. And then you have those C# developers that came to AL and they are saying, AL is too simple. It's hard to implement the complex logic. I need inheritance. Like in other languages, AL is bad. And then those C# developers might say, I will use code unit as an object with logic and state inside. I will pass it through all my logic in the application, populate the values in different places, and then at the end I will call these public methods on this class, this code units. But then you have AL developers. You see, they will see this solution and they will look at it and say, "I don't understand this code. It's too complex. It's too complex for me. I cannot work with it." And also, when I was looking at some YouTube videos made by JavaScript developers, they were also complaining that OOP is bad, we should not use it, we hate it. So I was thinking, what's wrong? Why we have all those problems? When I was thinking about it, let's go back to the beginnings of OOP. And those beginnings, the old term of OOP was formed by Alan Kay, and what he said is he defined the OOP as, I thought of objects being like biological cells or individual computers on a network, only able to communicate with messages. That's what he said. And he said that because, like in every approach to development, he wants to convert this complex code, complex applications into something easier to understand, to separate functionality into some smaller blocks that will be easier for us to maintain. So that was his idea. And then, based on his idea, some class-based languages have been created. I'm using this class-based, not object-oriented languages. And class-based languages have been created, like Smalltalk, C++, Java, later C#. And they have classes, and they have encapsulation, they have abstractions, inheritance, polymorphism. And the creators of those languages focuses on those properties of those languages, on this part of OOP. But then Alan Kay said, I'm sorry that I long ago coined the term objects for this topic, because it gets many people to focus on the lesser idea. The big idea is messaging. Yeah, that's what he said. And then he said, OOP to me means only messaging, local retention and protection, and hiding of state process, extreme late binding of things. So for him he thought about OOP like, as he mentioned, about like a computers, like some maybe the microservice architecture will be closer to it, when you have some small apps just communicating with each other. So those were these Alan Kay ideas. And then let's go back to C#, to OOP in C# and some misleading C# example that can result in some suggestion to the not the best suggestion to the architecture of AL apps. If somebody tells you, that's how you do it in OP, let's do the same thing in AL. So here I have a concept. So imagine that desktop application, a graphic editor, and then you have the classes, like you have class shape, you have class rectangle that inherits from the shape. So you build in memory a picture, which is built from different types of shapes. And each shape has a state, like the position where it is, and it has a method that can draw itself on the screen. So this looks like perfect example for OOP, for this type of application. And it's good if you for a desktop application, because you start the app and it works all the time until you close it on your machine. So desktop application, graphic editor, a game, or a library, or some small libraries, small classes, like a collection, HTTP client, stream, then they will work very good with this architecture, with this approach. But it's not necessarily good for web-based database application. And I was really surprised, probably 20 years ago, or something like that, when I was, my experience was with exactly this approach in C# or in C++. And then I wanted to write I had to write a web application in C# using ASP.NET at that time. But before I started, I wanted to read the Microsoft documentation to understand how they see it, how it should be created. And when I saw it, I was really surprised. And it took me a bit of time to understand what they are doing and why they are doing it. So if you think about Business Central, this is rather our case. Yeah? Business Central, you have web client, application runs on the server, not locally on your machine. So what was that suggested way of creating web-based application in C#? Well, that was the idea. The idea was that, for example, imagine that we have the C# application that uses web APIs to do something. And to make it a bit simpler here, let's assume that we have a client written in C# and it's service written in C#. So the architecture for that type of application, as suggested by for this type of application, is that we have the application itself, the service, is stateless. So it doesn't have any state. It's not keeping in memory anything. The advantage of it is that if your server is too slow, you just create a new server, install the same application, and if you have a load balancer that randomly sends each message to the service that is less busy, then we can spread nicely the load to those services without having the situation where one service is more utilized while another is doing almost nothing, because once somebody started working with the service, once they started connection, they would have to be always sent to the same service. If you have a stateless service, then it doesn't matter. Each request can go somewhere else. And in this approach, what we're having is that the client is serializing the objects, stateless objects with just properties to JSON or to XML, sends them over the network to the service deserialize them from this text in representation to an object that has only properties, nothing else, no logic inside, and then this stateless service class gets that deserialized data, is doing something with it, and sends back again some objects that only have state, only have properties, no logic. They are serialized to text, to JSON or XML, sent back to the client, and client deserializes them and probably displays on the screen. So as you can see, we have this separation where we have classes with properties only and classes with logic only. We don't have the stateless classes with logic only. And what is interesting, when I saw one of these articles made by JavaScript developers, they said, oh, you don't even have to have any class-oriented language. Yeah, this stateless service could be a module, and this object that you're sending through network is a record or a structure. It again doesn't have to be class, but it still matches this definition of Alan Kay of OOP. And we still have messaging, which was more important for him. And so that's how those web applications look from outside. Yeah? Stateless services, an object being sent that doesn't have any logic. But what about the other side? What about the bottom of the application? What about the database access? For database access, again, it's similar. What we have is, when you're doing something in C#, when you're using Entity Framework, you define your classes that represent the tables, and they have very minimal amount of logic, many times almost no logic, and they don't know from where they are loaded. So they don't know where the database is. So you cannot, so that's the difference between C# and AL. Yeah? In AL, in a validation of the field, you can go to the database and get data from other tables, while in C# you don't, because data are loaded from the database by different class by something that is higher in this application structure. So you can only have very simple validations, like checking if the phone number is okay. So like in this example, yeah, we have this database context here, which is a data access layer, the class that loads the data or saves the data back. And then we can have this stateless service that's doing something, the class that's doing something, the document. Like in this example here, it will use this data access layer to load the data, will process it, and then we can use this data access layer, those classes from the data access layer, to save the data back. So as you can see, you have this separation. Yeah? You don't have logic in the sales header because we cannot have it here because it doesn't know where the other tables, other objects are. Yeah, so that's how this web-based database application in C# will look like. Yeah, we will have public API, which is a stateless service. You will have some processing logic, some layers with this logic. They may have some state, and then you have the database, which is non-object storage. Yeah? Those are tables. And when we're saving data, we're passing those classes that have almost only properties, maybe a bit of logic inside, very simple validations. So that's how it looks in C#. And that structure of this messaging application in C#. Yeah, we have the service layer that is on the top, that gets the requests or messages from somewhere, maybe from other libraries, not necessarily from network. When we have those stateless services, and those stateless services are then using some other classes from this business logic layer, so calling them directly and passing as a parameters the data, as classes data, or maybe some other service classes as dependency injection. And at the bottom, you have data access layer where, again, you have some classes that access the database, allows you to store the data or load the data from the database. They can be stateless, they can have some very minimum state. And again, you're passing to them the classes or objects that have just data inside, or maybe some services as a dependency injection. So that's the idea in C#. That's how those database applications are written in C#. Now, what about AL? So we could try to apply the same approach to our AL applications. Yeah, so we can think about it the same way. So what we can do is we can nicely split the applications into some smaller code units with just procedures that are operating on our records, for example, with a logic only there, and probably a few very carefully designed public methods. If you need, you can add some even public publishers there, and then try to avoid putting too much business logic into the records. Obviously, field or record validations are okay. You know, we have them in AL, that's fine. But having a procedure that are doing something on the record, the public ones, maybe it's better to move them to the separate code unit. So the validations, yes, that's fine if we keep it in the record, but for the rest, let's create a code unit. Let's think about this code unit, not like those old management code units, but rather as this is a service, a small code unit that is a service that can do something, a few operations on our records, operations that are in the same logical area of the app. So we can have some code units like a client, we can have page, report, code unit, which we can treat as a client, and then we can call some methods from another code unit, which is a service, and pass some records to it and get some records back. But it's more about the way we think about it than really something new for the for our AL world. Yeah, let's think about them as a service. Let's think about code unit as a small service that has some nicely designed, some minimal APIs. That's messaging. Now, what about this idea of Alan Kay as late binding? Late binding is then we can use interfaces. So instead of using code units, we can use interfaces, and then which will allow us to use different implementations. But I would say that don't use them if they are not needed, because it will be harder to debug and harder to analyze the code. But if there is a case, then you can use the interfaces. So then this service will be an interface, and instead of a code unit. Something more about the late binding and inheritance. So inheritance is ability to create subclass that inherit code from the parent class, with possibility to redefine some of the methods, which is not available in AL. We cannot have inheritance. And I saw some attempts made by C# developers when they were trying to simulate inheritance in AL, and the result was very overcomplicated code, which was hard to understand to just AL developers. So I would rather try to avoid it if possible, and try to design the application a different way, if you can. But sometimes you may need something. So what we can use if you need some kind of inheritance, you can use encapsulation. And what I mean by it, that's the idea that I remember from a very old Visual Basic book from something like year 2000. At that time, Visual Basic had interfaces, but it was not possible to have inheritance in that old VB. So the suggestion was encapsulation. And what it means is, imagine that you have some interface in Business Central, and this interface has 20 methods or more. And you would like to implement your own implementation of this interface, but you would like to use it to be almost the same as a standard Microsoft implementation. Just one function needs to be slightly different. So you may have an idea. Let's copy the code from Microsoft and then modify it inside. But the problem with it is that if Microsoft finds a bug or changes something, you will have to go again and merge that code with yours. So what you can do instead of that, you can use the encapsulation, which means that you create your code unit, which implements the interface, and inside of your code unit, you create a global variable of the type of the Microsoft code unit. And then what you will do, you will just, in every method that you don't want to change, you will call the Microsoft code unit. And in the method that you want to modify, maybe you will call the original code unit and then modify the result or check the result into something different, or just replace completely the logic. This way, if Microsoft changes something in their implementation, you will automatically get the new behavior. And also, you can use event publishers for some of the cases of inheritance, but only if you want to have a notification. So you have to send message to some other objects. But avoid over-engineering and don't do it if you don't need it. And make sure that you design your event publishers, not to put them absolutely everywhere. Okay. So here I have just this example of late binding as encapsulation, how you can do it in AL. Like here, as you can see, you can have this base global variable, and then which contains this original Microsoft code unit, and then when you implement the methods, you can just call base.getNumber or base.verify payment, and then put our custom logic here if you want to change something. So now I still want to talk about inheritance and the issues with the inheritance. So the problem with inheritance is, like in this example that I have here, the example that I showed you at the beginning, I have the shape and I have the rectangle that inherits from the shape. And the problem is that when you design the application this way, it's very tempting to start adding methods, adding the behaviors to the shape. And the result is that almost all the logic goes to this base class, which start getting really, really huge. Those classes that inherits, like rectangle here, that inherits from the shape, probably will have just a few methods that are just changing the behavior, while this 99% of the logic could be in the shape. So you can imagine that this original, the base class, will be really hard to maintain. Will have absolutely everything, which then implements this God object anti-pattern. And it's very easy to get there if you're designing application this way. So the solution for that is composition. So composition means that you can split this big class into smaller. Obviously, with the example from previous screen, it could be a bit tricky because you have a lot of methods operating on internal variables that are not visible outside. But if you apply this service approach, the one that seems to be much better for the web applications. So with the service approach, it's not complex. Yeah, you may start with the service called sales orders API. Yeah, we can think about the service as APIs, and then when it gets too big, you can split it into smaller services. So posting API, prices API, discounts API, warehouse API. Yeah, so smaller services doing something smaller, working only with this smaller set of functionalities, and this way also gives you nicer separations. If you have other extensions from other ISVs, and they also provide some service code units, then you can clearly see in your code which one you're calling. If everything ends up in the function in the table through table extensions, for example, then yes, you have all methods in the table, but you really don't know which one is provided by which ISV, or if it's a standard, you may not be able to see it. While if you treat those code units as APIs, as services, you can clearly declare in your code, I'm using now approvals API from ISV1, and all methods are going through this service, or calls are going through this service. And as I have mentioned, it's easy to add new independent APIs later. The calls that the methods are not ending up in a table. So the question is, as on this picture, where should we split? Where is this moment when our API and when our service is too big? And some people may not disagree with this, but I saw it on a few places, in some blogs that, and I think that I agree with it, is that your file, your class, your object is too big if your code contains region directive. Because whole idea of the region is, my code is hard to read, I have too much here, let's just fold it. And you need to fold it because it's too big. Yeah? It's hard to read. Yes, I understand. You can fold just single procedure, but the whole purpose of region is to hide complexity. So maybe that could be a sign that this object is too big. And I have to say myself, yes, I am also guilty. Sometimes I'm creating some classes in C# that have too much. I have some regions there, but this is the message to me that I should take a look at it. And something is is not going well in this area, and this object is slightly too big. And I probably should think about redesign. And sometimes you have no choice, but it would be to avoid. So that was C#. Let's go quickly back to AL. So let's go back to this layers idea. So what you can do, how you can do messaging in AL, you can create those code units, and think about them as stateless services, or maybe almost stateless. You may still need to keep something internally, but try to minimize those number of those global variables in a code unit. If you don't have any, that's the best best thing that you can have. So you can logically just split your code units into different layers in your application, and then try to keep them stateless, pass records to them, to the functions that you are calling, maybe use dependency injection to pass some code units and interfaces to them, and at the end have some, so declare some public APIs, create some code units that are more logic, that they're implementing some business logic, maybe some lower level business logic, maybe some tools, but think about them as services, giving you some functionality, some APIs to do something. And how it can look like? Let me just quickly show you an example how those services could look like. So I will just open quickly an example. And here, what I have a simple example. I have the sale document sender code unit. So that's a service that is sending documents. That's how I think about it. And it has the send posted invoice and send posted credit memo methods when I can pass the record. So this is the API. This is the service that is doing something. And inside, I'm using some other code units from some maybe lower level services or APIs that I have my application. So I have a code unit that can upload file, I have a code unit that can print documents. So I'm just printing the document, which will print it to the temp blob and give me a file name of this temp blob. And then I can use the file uploader to upload the file somewhere. And here in this another folder in application, I have this different layer with those tools. So like this file uploader or some notification sender. And here in this base layer, I have those code units operating on my data, on my documents. So sales document sender, sales document printing, or sales approvals. And they could be here in this different layer. And with the latest AL with namespaces, I could then nicely separate them into separate namespaces, representing different, not only areas of the application, but also layers of the application. So that's this simple example of this service way of thinking about AL code. And then we have this another subject, which is dependency injection. So instead of declaring the objects directly in our code, we can pass those code units to our methods, which allows us to run code with different implementation of this dependency. So for testing, we can pass something else to the procedure. It can help us with this, with test-driven development, where we can pass to our services some other fake services for testing to make our tests faster. But the disadvantage of it is that it could be harder to read, because suddenly we have a lot of interfaces, not the real code units that have some logic inside. Example of it, let me just show you quickly. Open dependency injection. And here is example of dependency injection of the same logic. So again, I have a sales document sender service or API, which can send posted invoice or send posted credit memo somewhere. But this time I'm passing the file uploader as the interface. to the method, and then the rest of the logic is exactly the same, but because I'm passing interface, which is defined here, interface with just upload file method, I can have different implementation. I can have SharePoint file uploader, FTP file uploader, or I can have some fake uploader for testing when I want to test the printing, but I don't want to send the file anywhere because it will be slow, and whole unit test suite will be much slower. So with dependency injection, I can make it faster. And the last slide here is just a summary of this presentation. It's OOP subject, OOP in AL. So what we can do, how we can start thinking differently about the code, is that we can start thinking about our code units and interfaces as APIs of some stateless services, and we can design them this way and create a code unit with just a few public methods, which cover some small set of functions around the same functionality. We can split the application into layers, so we have those higher level code units, lower level code units, and to avoid God objects, we could use composition, and be careful with the region keyword, because if you have them, then probably your classes will be too big at this moment. And we should also avoid making tables and God objects. Now let's keep just data fields in a table and the validation logic only. But if we have any methods that operates on those tables, then it should be a service. Yeah, we should not create a method in the table that will call the code unit. Let's call the code unit directly in our code. Let's not go through table, because that's not how these C# applications are created. Yeah. Let's keep the separation. Let's keep this data layer with tables and the business logic in the services. If you need multiple implementation of those APIs, then use interfaces. Yeah? And if you need with these interfaces, if you need, you can use also encapsulation, as I showed in the example earlier, for calling some different implementation of the same logic, use event publishers, and you can use composition dependency injection in those with the interfaces. And also one important thing is learn development patterns. Go to AL guidelines.dev, read about the patterns, but also try to understand when those patterns are needed. Don't use them if they are not needed. Don't overcomplicate your application if you don't have to. So those are the subjects that I wanted to cover today, and I think that's it what I have. So if there are any questions.
Thanks, Andrzej. I see no questions, but I've just one question. Is especially, I think this is a really good approach, and you explain it very well. But if you've got a quite large solution already, for example, you've got a feature with a lot of code in it. What's the best approach to make a really good composition about it? What you said about the layers from the stateless, and on top of that, all the APIs, and separating all the functions in smaller code units.
What I can tell you is, like, take a look at those bigger code units and try to split them into smaller parts and separate the logic, because then it will not only make this code more readable, but also will help you with, if you want them to have some nice test code units, test extension that will test your application, then it will be easier to test those smaller blocks. But what I can only advise is just take a look at those big code units and try to. If you see that you have different areas there, you can try to split them. Yeah? Or if you see that you have huge blocks hidden, collapsed inside the regions, maybe that should be now for each top level regions. Maybe you need to create separate code units with those functionalities, because probably you already grouped them inside. Yeah, you probably somebody already did some work collecting functionalities together inside the region. So half of the job is probably done. Not half, because then you will have to redirect calls to a new code unit everywhere in your app. That was my tablet telling me that it's 45 minutes. So you can split it, and this is also a very good example, very good question, because of the question and the example where you should not over-engineer your solution, because one of the patterns is the facade. Yeah, if you go to AL guidelines, or if you go in general to development patterns, there is pattern called facade, but which allows you to hide your implementation. You're putting as an object, a code unit, something as a facade, and then you have implementation somewhere else. But if you always be doing facade and the implementation behind, the question is, are you not over-engineering it? Do you need a facade? While the example that you mentioned, that's a good case for facade. You have this big code unit that you have in your application with a lot of methods. What you can do, you can create those service code units with the smaller services, smaller APIs into separate code units, and just leave in your code unit, in the old code unit, get rid of all the code, and just put one-liners in each method, redirecting code to the new APIs. And now your old code units, big code units, the logic becomes a facade. So you can think about it also like this way. You have APIs, version 1 APIs with a lot of logic inside. And then you think, oh, let's create version 2 of our APIs. So you can create version 2, version 2 of APIs, and then version 1 APIs became a facade at this moment, because you just redirecting calls to version 2, just populating maybe some default parameters that are not available in version 1. So then everything that is still using version 1 of those APIs, version 1 of the service, still works, but all the logic now goes through the new APIs version 2. It's just redirected by the facade.
Yeah, perfect. Indeed. Thanks, Andrzej. And there are no other questions. Thanks, Andrzej, for presenting this, and very clear, and especially in the end about the facades. That's also, I think, I need to mention that here in my organization. So thanks all for joining. Having a good day. And what I said, if you want to email us, go to webinars@areopa.academy and subscribe to the newsletter and YouTube. So thanks for all, and see you the next time.